Hey everyone, and welcome. Today we are diving into something that sounds complicated, but is actually a kind of mathematical superpower. I'm talking about trigonometry. Seriously, it's the tool that lets us measure things that seem totally unmeasurable. So, you're ready to get started? So let me ask you a question. How in the world would you measure the height of a massive mountain without actually having to climb it with a giant tape measure? It sounds like a brain teaser, right? But the answer isn't some kind of magic, it's math. And this is exactly the kind of problem that trigonometry was made to solve. Okay, so what is this amazing tool? Well, when you boil it all down, trigonometry is simply the study of the relationship between the angles and the sides of triangles. And for our purposes today, we're going to focus on the real hero of the story, the right-angled triangle. Now, before we can start using this superpower, we have to learn the language. It's kind of like learning the names of your tools before you start building something. Every right-angled triangle has three sides, and each one has a very specific name. So let's get acquainted. First up, we've got the big one, the star of the show, the hypotenuse. This is always, and I mean always, the longest side of the triangle. The easiest way to spot it? Just look for the right angle, that little square in the corner, and the hypotenuse is the side directly across from it. Easy. Next up is the opposite side. Now, this one's a little tricky because its name depends entirely on your point of view. See that angle we've marked X? If you're standing at that angle and looking out, the side you're looking directly at, well, that's the opposite side. And finally, there's the adjacent side. Adjacent is just a fancy word for next to. So this is the side that's right next to our angle X. But wait a minute, the hypotenuse is also next to the angle, right? Right. That's why the adjacent is the side next to the angle that is not the hypotenuse. And that's it. Now we know the language. Okay, we know the names of the sides. Now we're ready for the real magic. We're about to learn the three core ideas, the three main ratios that are the heart and soul of trigonometry. Think of these as the secret spells that connect the angles to the sides. First on our list is sine, which we usually just write as sin. The sine of an angle is just a ratio. Specifically, it's the length of the opposite side divided by the length of the hypotenuse. That's it. It's a simple but incredibly powerful idea. Next in our lineup is cosine, or cos for short. This one is pretty similar, but instead of using the opposite side, it connects the adjacent side to the hypotenuse. So the cosine of our angle is just the length of the adjacent side divided by the length of the hypotenuse. And our third and final key player is tangent, or tan. This ratio leaves the hypotenuse out of the picture and focuses only on the other two sides. The tangent of an angle is the length of the opposite side divided by the length of the adjacent side. And there you have it. Sine, cosine, and tangent. the big three. Okay, I know what you might be thinking. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is, wait, what was it again? Yeah, it can be a lot to keep straight in your head. But don't you worry, mathematicians came up with a brilliant and super easy way to remember all of this. I want you to meet your new best friend in trigonometry, SOHCAHTOA. It sounds like some kind of ancient chant, right? But it's actually the key to everything. So tells us that sine is opposite over hypotenuse. Ka tells us cosine is adjacent over hypotenuse. And TOA tells us tangent is opposite over adjacent. Just say it to yourself a few times. So, ka, TOA. It's pretty much unforgettable. Now, usually, you'd punch an angle into a calculator to find its sine or cosine. But here's a really cool part. For a few very special angles like 30, 45, and 60 degrees, we can find the perfect, exact answer using nothing but a little bit of geometry. No calculator required. So let's figure out the values for 30 and 60 degrees. Picture an equilateral triangle. You know, one where all the sides are equal. Let's say each side has a length of 2. Now let's slice it right down the middle. Poof! We now have 2 identical right-angled triangles. The angles are 30, 60, and 90 degrees. We use a little Pythagoras magic, and we find out the height of this new triangle is the square root of 3. Now that we have all 3 side lengths, we can just use SOHCAHTOA to find the exact sine, cosine, and tangent for 30 and 60 degrees. And we can pull off the same trick for 45 degrees. This time, let's start with a simple square where each side has a length of 1. Now slice that square corner to corner, diagonally, and what do you get? 2 perfect right-angled triangles, each with angles of 45, 45, and 90 degrees. Pythagoras tells us the new hypotenuse is the square root of 2. And once again, with SOHCAHTOA, we can find the exact values for everything at 45 degrees. So after all that slicing and dicing of shapes, what have we actually accomplished? Well, we've built the ultimate trigonometry cheat sheet. This is literally the master key that unlocks the exact values for the most common angles you'll ever see. Let's have a look. And here it is in all its glory. This beautiful little table shows all the exact values we just figured out, plus the values for 0 and 90 degrees. See right there? The sine of 30 degrees is exactly 1/2, just like we found by splitting that triangle. This table is going to be incredibly useful anytime you're solving these kinds of problems. Now, you probably spotted that one weird entry in the table, undefined. What's that all about? Well, think back to SOHCAHTOA. Tangent is opposite over adjacent, right? In a 90-degree angle, the adjacent side basically shrinks down to a length of 0. And as we all know, dividing any number by 0 is a huge no-no in math. The universe just doesn't allow it, so we call it undefined. And there you have it. You now speak the language of the right-angled triangle. You know the magic words, so, ka, toa, and you even have the key to those special angles. Trigonometry is everywhere, from figuring out the height of mountains to designing buildings and even in the code of your favorite video games. So the only question left is, now that you have the key, what secrets are you gonna unlock?